Hello, I'm Meteorologist Jeff Matthews, and you're on the module, How do Storms Form and How do we know if it's going to be rain versus snow? First, let me explain to you this is going to get just a little bit complicated, and that's okay. You can always watch the video again, plus at the end we'll have a demonstration for you that will really help put all of these pieces into one puzzle that'll be easier to see. Let's start with the obvious. As a meteorologist, we would look at things like the radar and satellite pictures to be able to determine where there are obvious things going on. So as we look at the satellite picture here, this is the eastern half of the country, and there's clearly a line of light blue and white that is moving towards the coast. So that's an obvious place for me to look and see that there's something going on here. The same can be said for this patch of cloudiness that's moving down from Canada into the United States. So these are ways we can get an idea right off the bat where fronts are located, where storms may be located, and where fair weather may be located as well. Second thing to note is that over time, it becomes obvious that storms take certain paths. Think of it like this. You wouldn't look for a car in a cornfield. You wouldn't look for a car to be passing you by on the ocean. Where would you look for a car to pass you by? On a street or a highway. Why? Because that's where cars belong when they move. So when you get in your car and drive, you don't drive through a cornfield or across the ocean. You drive on a street or a highway for a reason. The same thing can be said for storms. Once you find them, we have an idea from their history what direction they tend to go based on where they're at right now. And the same can be said, by the way, for high pressure systems, which are the opposite of low pressure systems. And this is a good time to point out that they have different names, and that's okay too. We generally call low pressure systems either low pressure, or they could be called a cyclone. They're the same thing. We designate them on a weather map with the letter L. The opposite would be a high pressure system or an anticyclone, anti meaning opposite. So it's the opposite of a cyclone, an anticyclone, a high pressure area, and therefore it gives the opposite weather that low pressure areas give. Low pressure areas tend to give clouds and rain. High pressure areas tend to give clearer skies, and their temperatures are based on where they come from. So if a low pressure system or a high pressure system comes from the south, it would bring warmer temperatures most of the time. If they were to come out of the north from Canada, they would bring colder temperatures. So in an example, this storm is a low pressure system or a cyclone. And it's moving across the United States from Canada. So it would bring increasing clouds and rain and then colder temperatures based on where it came from. This storm or cyclone or low pressure system to the east of Texas, if it moved in our direction, would bring increasing clouds and rain and then warmer temperatures with it. And the same can be said for high pressure systems. Let's have a look three-dimensionally through the atmosphere to determine how we know what kind of precipitation is going to fall. You may or may not know that when you go above the Earth's surface, the temperature tends to drop off with height. So in other words, where you and I live, it might be 50 degrees. But a few hundred feet up, it starts falling off to about 40, 30, 20, 10, 0. However, because of these pressure systems, they upset the atmosphere vertically. And in low pressure's case, they can sometimes, depending on their path, cause warmer air to push in above the surface, above where you and I live. So, the precipitation in the winter may be falling as snow, it would hit the above freezing layer of air and melt. And then either reach the ground as rain, or if there's another cold layer below it where you and I live, it would refreeze as sleet. Or if the ground is frozen and it hit the ground as rain, it might freeze on the ground as freezing rain. So this is kind of a diagram of what it might look like for a particular storm. The storm is moving from left to right. It brings the clouds and then the precipitation and whatever kind of air that it brought with it, whether it's from the south warm or from the north cold. In this case, there's a wedge of warmer air that's coming in well above our heads. Can you see that? So in the beginning of the storm, it falls as snow and stays as snow all the way to the ground and accumulates. As the storm continues, it falls as snow, but it hits that warmer layer of above freezing air. That causes the snow to melt into raindrops, but that warm air is not very thick. So there's colder air below it again, so the snow that changed to rain now changes to sleet. Sleet pellets, which are different from hail, which we talked about in a different module. So it'll reach the ground as sleet, or frozen pellets. However, further into the storm, the warmer wedge is taller. And so the snow falls, melts as rain, reaches the ground as rain, but if the ground is frozen, it would become instantaneously freezing rain. And then, as we get into the heart of this particular storm, the snow falls into the warmer air, becomes rain, and if the ground is not frozen, it stays rain all the way to the ground. So as a meteorologist, we need to figure out what is it? Is it high pressure or low pressure? What direction is it moving in? How fast? And where is it coming from to determine what kind of air it's bringing with it? And then we begin to look three-dimensionally through the atmosphere to determine, is there any warmer or colder air in the middle of the storm to affect the kind of precipitation that will fall and reach the ground for you? It's important to know that, not only for driving, but it might mean a snow day for you. Okay, it's time for our quiz. Are you ready? Pen and paper out. Have your thinking toque on. Question number 1. What other names are there for a storm? I mentioned several of them. Question 2. How do we know where storms will go? Question 3. How do we know the type of precipitation that will fall? We'll take a moment and have the answers. Okay, what other names are there for a storm? You could call it a low pressure system or a cyclone. And the opposite can be said for a high pressure system, which brings good weather, high pressure or anticyclone. Meanwhile, question 2, how do we know where storms will go? Well, the jet stream directs their paths, and we know from watching previous storms over the last centuries where storms tend to go. How do we know the type of precipitation? Well, that answer is by looking three-dimensionally to determine the temperature of the air all the way from where the snow or rain begins all the way down to when it finally hits your head and mine or the ground. That's how we know what type of precipitation. We have to look through the cloud to the ground to determine what the temperature is all the way from the top to the ground. That concludes our module on storms, rain versus snow. Now I think I have an interesting experiment for you to enjoy. Hello and welcome to our experiment that helps demonstrate to you how storms form and how their oppositions form as well. For this experiment, I have here a container that's mostly filled with water. The water is room temperature. If you look on this side, you see a little glass that's filled with blue. It's blue-colored water. There's nothing else in it. It's just water, but it's blue because of food coloring that I poured into it. I've also frozen it. So it was in the freezer until it became an ice cube. So it's cold. On the other side, I have a little red dye, which is the same thing that I poured in that container, except it was blue. The red dye is going to represent warm air. The blue dye is going to represent cold air. And see what happens when they meet. When I pour them both into the container of water, they're going to eventually meet together. And I want you to look carefully through the front face to see what happens to the blue and what happens to the red. So here we go. On one side, I begin pouring the red dye. That's the warm air. On the opposite side, I carefully, because I don't want to disturb the water, put in the blue ice cube. I want you to watch through the face what happens when the cold meets the warm. Yes, they do turn a different color, but more importantly, if you look carefully, what you see, and I'll come around so you can see it better, the warmer is going over top of the colder blue. The red is trying to go over top, and the blue, if you notice here on the bottom, is sinking very low to the bottom of the container. So as a result, when you get warm air, like from the Gulf of Mexico to our south, clashing with cold air, like from Canada, and they meet, two things happen. First, they blend into a storm, and second, the warm air goes over top of the cold air. And that's how you get a storm to form. And it's referred to as low pressure or a cyclone. And the reason it's referred to as low pressure is because the air in it has a little bit lower pressure than the air outside it, or high pressure. So high pressure is a bubble of dry air. It could be cold if it comes from Canada. It could be warm if it comes from our south. But more importantly, the air pressure around high pressure is a little more than the air pressure in low pressure, which is now full of moisture and warm air going over top of the cold air. And so as a result, that forms a storm, and that brings the precipitation, and it also brings the warm air if it goes by to our west, or brings the cold air behind it if it goes by to our south and east. And by the way, in terms of forecasting, this is very important for me to know, because if there is warm air coming over top of the cold air, that will determine what kind of precipitation falls from the cloud. Will it be snow, snow to rain, snow to sleet, or just plain rain? So knowing the three-dimensional temperatures helps me to know what type of precipitation is going to form from low pressure as it moves through. I hope that helps you understand how storms form and why they form.